Our next talk is coming up in just a minute. It's Will Porter. What he's going to do is he's going to look at a CVE. He's going to look at the developer that contributed to that repository, and then do more research on what other projects that developer has done to find other CVEs, if I got it right. And then I'm going to cut over right now. Just one quick thing. Make sure you guys check out the Palo Alto Discord channel as well. They have a raffle there for a one-of-a-kind branded cooler and rocker glasses. Stuff there. And also Knox, in their Discord channel, they have a raffle as well. So please, when you get a moment, stop in there and say hi to those guys. So coming up next is Will Porter. Let me bring him in.
Hey, can everybody hear me okay? Bueller.
I can hear you.
All right, sweet. Hey, everyone. My name is Will Porter. I'm doing the next talk. It's called Stalking Known Open Source Offenders for Novel CVEs. That description of it was mostly right, except for instead of, in this example, I wasn't looking at other projects that the author had written to, but actually the same project, but finding other areas of the code that had been made vulnerable by their other commits. But I have some slides. I will share them now. All right. How do I share my screen again?
Click up top in the window that you're in. You should see a, when you hover over, a menu should pop up on the top of your window.
All right. Where on the top of my video?
So were you in the video window that you can see yourself in?
Oh, right. Okay, awesome. Thank you. All right. So, like I said, this is called Stalking Known Open Source Offenders for Novel CVEs. Basically, the talk is a methodology to kind of quickly identify new vulnerabilities in code based on existing vulnerabilities in open source projects. It was a methodology I created because I wanted to be able to find new vulnerabilities a little faster than just performing a full web security assessment on a open source project. So let's get into it. So a little bit about myself. My name is Will Porter. My GitHub is up there. It's github.com/mynameiswillporter. I'm a hacker, a developer. I put husband and homeowner on there just because I recently bought a house and I didn't realize how much time I was going to wind up spending on that. So that's most of my hobbies now. But industry-wise, I've been employed in things from 3-person startups to Fortune 50 companies, either doing development work on authentication systems or most recently I was a senior security consultant in the consulting space. So let's go over the agenda of what we're going to do today. So I'll give a little bit of background about how I came up with this idea, and the background revolves around a specific open source vulnerability. I'll talk a little bit about the hypothesis that I had, and then walk through actually testing the hypothesis in the case study of a particular open source repository, and then just how it led to the discovery of novel vulnerabilities. And then if we have a little time at the end, I'll talk about potential future steps that people could take to improve this methodology and make it automated or something like that. All right, so just before we start, I want to go over some terms that people may or may not be familiar with, just not to assume anything. But so the first thing is a CVE. So that's the common vulnerabilities and exposures. And basically, it's a list of records containing an ID, a description, and at least one reference for a publicly known vulnerability. And generally, a vulnerability that's assigned to CVE is something that is a vulnerability in a common piece of software or something that many people use. Open source, it's just software released under a license that grants users the rights to use, modify, or distribute the source code. We'll be focusing in this presentation on OpenEMR. Now, this is just an open source electronic medical records implementation, and that's kind of where I tested this hypothesis. So I also want to tell everyone about parameterized SQL queries. And basically, a parameterized SQL query is just a SQL statement where dynamic data is supplied via parameters. It's precompiled, and it's a common method of preventing SQL injection. Cross-site scripting, it's an injection attack where malicious scripts are injected into otherwise trusted sites. Basically, a vulnerability that allows an attacker to execute arbitrary JavaScript in a victim's browser. And weakness. And now a weakness isn't necessarily a vulnerability, but it's a coding error that could lead to a vulnerability. And that concept is kind of pivotal to this methodology. All right, so anyways, let's start with a little bit of background about a specific vulnerability and how this whole process came to be. So the background is this vulnerability identified as CVE 2018-17-179. And basically at Defcon 27, me and actually some other people in this chat, I think, were at Defcon 27. We decided to do the Biohacking Village CTF. And basically it was about a 3-day long CTF with a bunch of different sections to it. And one of them was it brought you to a website, and the instructions were something along the lines of extract John Doe's social security number from the application. After poking around at the website, we were able to determine that it was OpenEMR version 5.0.1.1. And basically pulling up the CVE details for this version, we saw that there was a SQL injection vulnerability, and that seems like a perfect candidate to do something like extract John Doe's social security number from the application. Now, there weren't any specific public exploits for this vulnerability at the time. I know if you're fact checking me right now, it might say there's a Metasploit module for it, but that's I wrote that after the fact. So don't worry about that. Also, you could use SQL map to exploit this, but that's not what we did. We pulled up the source code and were able to engineer an exploit for it based on the source code. So that's what we did. And basically, the CVE, the description is that there's a SQL injection in the make task function in this specific file name, taskmanfunctions.php, and it says via another file. But basically, the CVE description itself tells you that there's a SQL injection. It tells you what function it's in and what file it's in. And now, earlier, as I explained to CVE, it contains identifier. In that case, this is the CVE 2018, blah, blah, blah. It contains a description, and it contains references. Now, the references are going to be pivotal to this methodology that I'm describing, because sometimes for open source projects, the CVE references contain a link to the commit that fixes the vulnerability in the code base. And that's actually exactly the case here. So one of the references for this CVE is a GitHub commit. So basically, it links to a commit that fixes the vulnerability. So if you were to load that commit in GitHub, you would see that it brings you here. The commit's named bug fixes. And if you scroll down, you'll see that the diff for this commit is actually, if you know what you're looking for, going to be obviously fixing a SQL injection. And you can see that in the red, that's the part of the diff that's being removed via the commit, and the green is what's being added. So basically, this commit is replacing these two lines, 97 and 98, replacing this code with this code. And what this is the original was an non-parameterized SQL statement where this potentially dynamic data is just inserted into the SQL statement, causing a SQL injection vulnerability, and it's replacing it with this newly parameterized SQL injection. So using the CVE, we're able to see that this is the commit that fixes this vulnerability. So why is that important? That's important because by seeing these commits that allow you to, that show you the vulnerability being fixed, you're able to work backwards and identify who actually introduced that vulnerability into the code base. And what happened was I had done the CTF, that was fun. I wrote a Metasploit module, that was fun. And then I was thinking, like, what else can I do that seems kind of fun? And since we were able to exploit this vulnerability with relative ease, having used the CVE, I was thinking, why can't I just find something that doesn't already have a CVE and file a CVE for it? So basically, I was like, oh, I could just test the entire web application. Or is there any way that I can just kind of minimize my effort to start finding vulnerabilities? And what I came up with was kind of this. So this is predicated on a few facts. So CVEs filed for open source projects sometimes have links to repository commits, specifically commits that fix the vulnerabilities that they're discussing. By finding the commit fixing the vulnerability, it's more than likely possible to find the commit where the vulnerability was introduced. And by finding that commit, you've effectively found what person introduced that vulnerability into the code base. And I kind of think of human behavior in the sense that the best predictor of future behavior is past behavior. So if somebody's if somebody's writing non-parameterized SQL statements in this specific already discovered vulnerability, it's likely, because coders code in idioms. I've reviewed so much code in my life that I find that people tend to write code the ways they speak. Like, I use specific slang words, things like that. I have a mannerism of talking. People also have ways of coding. They reuse idioms over and over, different paradigms. So I'm thinking that if this person committed this non-parameterized statement to the database, how do we know that we found all of them? There's no reason to think that. So if we could just analyze this person's commits, we're likely to find other vulnerabilities of the same nature of ones that have already been assigned CVEs. So that's basically the hypothesis. I wrote it up more succinctly here, but I think I pretty much gave the point. But anyways, by examining CVE references containing links to Git commits that patch security vulnerabilities, it is possible to determine the commits that introduced the errors. By identifying the author of the vulnerable commit and examining all commits produced by that individual, it is possible to discover novel vulnerabilities that had previously been undiscovered. That's basically the gist of this entire talk. It's pretty simple in concept, and the rest of it I'll just walk through a case study showing that this did actually work for me when I tried it. All right, so identifying the author of the CVE, that's tantamount to this process. So let's see how we would do that. So let's use the vulnerability we were discussing before and find that vulnerability's author. So basically, that CVE included a link to a commit that fixed it. And so we found the commit that fixes the vulnerability. But using this, how do we find the commit that introduced the vulnerability? So that's what we're going to do now. So this is kind of the process I made if you wanted to do it in GitHub. You could also probably just as easily figure out a process to do this in Git. But basically, what you do is you go to the commit that fixes the vulnerability and take note of the file and the line that had the vulnerability on it before it was fixed. So then what you can do is you can navigate to the parent vulnerability, the parent commit So for those of you familiar with Git, or maybe not familiar with Git, basically Git stores changes to code, and these changes are stored in a tree data structure. So basically, any point in time, there's a node that represents a change to a code base, and then one or more children nodes that are changes from the state that the parent node represented. So basically, in Git, anytime you have a commit, unless it's the first commit, there should be a parent commit. So basically, what we're saying is go to the commit that fixes the vulnerability and then find that commit's parent. That commit's parent will be the last state of the code base where that vulnerability was present in the code. So basically, by going to the parent vulnerability, we've reverted the code base to a vulnerable state. So Git then has a feature where you can browse the repository at that point in time. So basically now what you can do is you can browse the repository as it was during the parent commit, and then just navigate to the vulnerable file. And that file should contain the vulnerable code since you've navigated backwards in time. Then what GitHub has is a blame feature. And what the blame feature does is it goes through every line of code in that file and links it to the commit that made that line of code the way it is at that point in time. So if you're familiar with it, you probably know exactly what I'm talking about. If you're not familiar with these features, I'll just kind of walk through what they look like a little bit. So step one was take note of the vulnerable file and the vulnerable line of code. Now, if you pull up the commit that fixes the vulnerability, whatever is highlighted in red is what's being removed, and what's highlighted in green is what's being added. And you can kind of see they have the diff notation, so it's minus minus for being removed, plus plus. You can also do a similar thing using Git, the command line program. So we've taken note of the file name and the vulnerability. So it's this file and lines 97 and 98. Step two, we navigate to the parent commit. I've already kind of described the tree structure, but when you pull up this commit in GitHub, so this is the commit, but next to it, it says one parent, and you can actually click that, and then it will load that commit. So this is the parent commit, and if I go back and forth, so this is the commit that we were looking at that fixed the vulnerability. This is the commit parent, so it starts with 4850FF9. You can see that we've actually moved back in time to that commit. So now that we're at this commit, this should be the last commit where the vulnerability is still present in the database. So now we can go to Browse Files, and that will show us the entire repository at this vulnerable point in time. So basically, this is just some screenshots of me navigating the database or the repository at that point in time. And what we do is you can open up the file just like you would, but you'll see the state and time is still in that vulnerable commit. So we're in that vulnerable commit. I talked about the blame feature, which will go through every single line of code and show you what commit caused that line to be in that state. And when we do that, we see that, hey, this is our vulnerable line of code. This is a non-parameterized SQL statement. This is what we exploited as part of that vulnerability. But over here, it associates that these two lines are due to this commit, this iForm module commit. So by clicking that, we can basically bring up this next screen, which shows you the commit being introduced into the code base. Now it says, Afthal authored and Brady Miller committed. So what does it mean that somebody authored a commit and somebody committed a commit? Basically, this is common when there's something like a merge request. So in this case, Afthal is ostensibly the person who wrote the code, and Brady Miller just submitted a merge request, and Brady Miller merged that merge request. So knowing this information, I might I'm interested in looking at commits that Ophthal authored, because I think he's the one that's introducing these non-parameterized SQL statements. But also, it might be worthwhile looking at merge requests that Brady Miller merged, because he didn't catch it as part of the merge request. That being said, the amount of code that Ophthal authored is, in this project, substantially less than merge requests merged by Brady Miller. So to find the more specific, the most probable method of finding a vulnerability, we focus on commits that Ophthal authored. All right. So just to recap, so Ophthal is the GitHub user who introduced this vulnerability into the OpenEMR database. Now, actually, not part of this presentation, but in general, I repeated this process for every vulnerability in OpenEMR that had a link to a commit that fixed the vulnerability. I found that 11 users had committed vulnerabilities to the OpenEMR repository. In many cases, these users had introduced more than one vulnerability into the code base. So that kind of gave me a little more confidence that this was going to work, that I was going to be able to find novel vulnerabilities by looking at known offenders. So in this case, I also found another there was another vulnerability in the common vulnerabilities and exposures database that I was able to attribute to Ophthal. So now I kind of see that he has two publicly discovered vulnerabilities. And if I remember correctly, both of them were both due to non-parameterized SQL statements. So I'm starting to see that this is a thing that he does, or he or she, I don't actually know. So identifying the author's commits with weaknesses. So like I said, when I began this experiment, Ophthal was definitely responsible for 2 CVEs in OpenEMR. So also when I was looking at the commits, even though the 2 vulnerabilities associated with them were SQL injections, actually looking at the commits that introduce these vulnerabilities, I also saw other weaknesses, like unencoded dynamic data being echoed into an HTML document, like something that could possibly cause a cross-site scripting vulnerability. So my hypothesis would lead me to believe then that Ophthal may have introduced encoding errors in other commits or non-parameterized SQL statements. So let's take a look. So basically now what I want to do is we've identified the author who authors vulnerable code. Now we kind of want to look at all their other commits and see if there are other vulnerabilities lying there. So there's 2 ways that I have included here to do it, and one is through GitHub again. You can just basically, if you go to the commits endpoint and use the query parameter author, you can just supply an author, and in the browser, it'll just show you a list of their commits from most recent to most in the past. Now, if you prefer to use the command line, you can use the git command. So the gitlog also has an author flag that allows you to specify an author and will allow you to just view commits from that author. Note that, as we discussed earlier, you want to focus on the author and not the committer, since the committer might have just merged a vulnerable merge request rather than have actually authored the code that was vulnerable. So moving on. All right. So this is what it looks like if you view the author's commits in GitHub. Basically, if you load this URL, you just see a list of their commits that you can click on and use on the website. This is what it looks like if you use gitlog to try and accomplish this. Basically, the gitlog author equals command loads this kind of interactive gitlog style display. But what I found a little bit more useful was to just dump a list of the commit hashes. That's also possible using the git binary. So you can give it a no pager attribute, which doesn't load the interactive one. And you can actually format the output of this. So the %h here just means just the commit hash. So this kind of command will just dump a list of commit hashes by that author. So what I was able to do was just dump the list of commit hashes, pipe it into WC, and find that there were 98 commits authored by Ophthal. I kind of tweaked this format parameter to actually, instead of just dumping the commit hash, output a list of links to those commits in GitHub. Now, the reason I did this was because I actually like viewing the commits in the web browser rather than anywhere else. It's just really quick for me to look at it when there's the red sections and the green sections, and I just think the overall diff experience is really good on GitHub. So that's why I chose to do it this way. If you were doing this methodology, you could do whatever you want. You could view these in the command line. You could probably bash foo or automate this like much more than this, but I just like viewing it in the browser. So as I said, there were 98 commits. Being able to view the red and the green and just like sitting down and chugging through it, I think it was really easy for me to just do it in the browser. So I skipped ahead a little bit. Right, so that's what I just talked about. All right, so armed with a way to view all of Ophthal's commits now, all 98 of them. I have 98 links. Let me just be sure and revisit what exactly I'm going to look for when I view all these commits. So, as I said before, this author is responsible for two published vulnerabilities. So let's just take a look at those vulnerabilities so we can kind of get in our heads what we're going to be looking for when we pump through these 98 different commits that they made. So this is the first one. It's what we looked at earlier. This is a non-parameterized SQL statement that led to a SQL injection vulnerability. You can kind of, for those of you who may not be familiar with code analysis or reading code, the reason this is a vulnerability is because that these are variables in PHP. They're possibly dynamic values, and they're just concatenated into this SQL statement. To use a parameterized SQL query, there would have to be the actual parameters, which would kind of present as this, but with a series of just locations with question marks in them. Additionally, this is the second vulnerability that they were responsible for. This also turned out to be a SQL injection, and this kind of also presents as a SQL statement with dynamic data merely concatenated into it rather than having the proper parameterized version. And if I had the whole file shown up, you would see that file name is actually the product of user input that comes directly from a query parameter. So you would know more clearly than this example. Whereas with this code segment that I've shown you, this may or may not be vulnerable. You would see that it was clearly vulnerable if you saw how file name was constructed. All right. So those are the two parts of their commits that contributed to the known vulnerabilities that they had. But I also noticed some other things when I was looking at their commits, like this, for example. In this, they are echoing possibly dynamic value straight into HTML. And this is a potential vector for a cross-site scripting vulnerability. So having seen this, I'm actually going to be looking for two things when I look through Ophthal's commits. I'm going to be looking for these non-parameterized SQL statements, and I'm going to be looking for this type of unencoded output just dumped into a HTML document or JavaScript or whatever unencoded output going to the wrong place. I'll just be looking for those kinds of things. All right, so now I have these 98 commits I have to examine. I know what I'm looking for. And basically, I just did it. I just sat down, chugged through it. Took about 2 hours. But what I did was I just looked at the red and the green sections because those are the diffs. You could just look at the diffs if you're doing it in the command line. And for every part that was introduced, I just looked for the introduction of a non-parameterized SQL statement or an echo of dynamic data into HTML. Like I didn't do any deep comprehension of the code going on. I just looked for these two pieces of things. So that's why I was able to do 98 commits in 2 hours, just because I'm not really understanding the code. I'm not taking the time to do that. I'm literally just looking for these two weaknesses that I know this author has done in the past. So I was able to chug through it. And when I find a weakness, I'm not even examining it for a vulnerability. Literally, all I did, I just chugged through it. And if I noticed a weakness in that commit, I just made a note. And so at the end of it, I had identified 14 commits that had obvious weaknesses. And if you remember earlier, a weakness is just a coding error that might lead to a vulnerability. And then I just have these 14 commits that are much more manageable than 98 commits. And so I can now, after doing this basic triaging, can take a look at these 14 commits and kind of examine them further for whether or not they actually contain exploitable vulnerabilities. So just to give you an idea of other things that might not have been vulnerable code, but things I tagged as weaknesses. I kind of have this. This is actually one of the commits that I tagged as a weakness. It might not have eventually been vulnerable for whatever reason, but you'll basically see that there's a function here that as part of the function, it takes this doc.id parameter and it kind of assembles this URL by just merely concatenating the doc.id with no encoding. It's just all of these weaknesses are kind of hinting that this author doesn't necessarily understand the value of encoding or the importance of it in terms of security. But somebody could, if they could manipulate this doc.id, could completely change the meaning of this URL. Something as simple as possibly adding an at symbol and making this all be a username password combo and then putting a different malicious URL afterwards, something like that. I don't know. I don't think this turned out to be exploitable, but this is something I would have tagged as a weakness. All right, so now we've identified the author, we've created a way to find all their commits. We've actually went through the commits and tagged a subset of them as containing weaknesses that were similar to what we had already seen from that author's coding style. So now let's just see how did this turn out in reality. So discovering novel CVEs is the next part. So I identified those 14 weak commits. Now it's time to actually take a closer look at each one. So this is the part, it's kind of out of scope for this talk, but I've spent a lot of time as a developer, so I'm very comfortable just like reading code. But that doesn't mean you have to do it this way. You could use the same methodology, and when you get to this part, you could just dump these files into, I don't know, a static analysis tool or something like that, or take note of the files and just, if you're comfortable doing dynamic web app testing, just dynamically test that portion of the web app. So here, me personally, I prefer to just do the static analysis because it's just quick for me to read code. But basically, this is a commit that I tagged as a weakness. And the commit basically boiled down to this section of code here. I edited this for the presentation, like these lines were interspaced, but there was a bunch of random other code that wasn't pertinent to the vulnerability between some of these lines. But so for example, here you have provider ID, which is, if you're unfamiliar with PHP code, what this line is doing is this is taking content from a query parameter in a URL and just storing it in provider ID. So this is complete user input. It's not sanitized or modified by the program. It's not encoded in any way. Encoding would be the better option. But basically, then you have the SQL statement. And what it does is it kind of pulls values from the database and then starts generating this long, strange concatenated string with commas and parentheses around it. Eventually, what you see is that what it's doing is dynamically generating a string containing values to insert into the database somewhere else. And what do you know? One of those values is actually the user input string that we can just input into a query parameter. So just by seeing this, I know there's an exploitable vulnerability. I don't even really need to test it at this point in time to know that this weakness is actually a vulnerability, but it's always good to test it anyways. But we already know what the query parameter is going to be. The query parameter is going to be provider ID. So this is also kind of out of scope for this talk, but I was able to find this exploit string that was able to, since it was in an insert into statement, the method I used to exploit this was using an error-based SQL injection. So basically, I used this update XML function to generate an error that it would then dump to the web page. So in this payload, what I'm doing is executing the version, trying to add it to a piece of XML, but doing it in such a way that causes an error. And that version is then output as part of the error message to the screen when this eventually crashes. So there you go. We've looked at a commit, identified a vulnerability, and now it's a CVE that turned out to be CVE 2019-16404. So we discovered a novel vulnerability and filed it. So basically the description was authenticated SQL injection in this file in the latest, until what was the latest OpenEMR version. And yeah, it allows you to extract arbitrary data from the database via a non-parameterized insert into statement as demonstrated by the provider ID parameter. Now, this is exactly, not only were we looking for vulnerabilities, but this is exactly the vulnerability we were looking for. We knew that this person committed weaknesses with non-parameterized insert into statements, and boom, it just took us right there. There wasn't really much guesswork involved. Some other ones, I think that was the only SQL injection that came out of some of these tagged weaknesses commits, but you know how we had noticed earlier that they just echoed some values to HTML without any encoding. Well, here's another commit where they just echo this PID value, and this too is controlled by a query parameter. So I believe this one was controlled by a query parameter where you could set the value of the PID. It's probably on the next page. Oh yeah. So that was a vulnerability. That was a novel vulnerability. So that resulted in CVE 2019-16862. And you can see here it's reflected XSS, and it allows you to execute arbitrary code in the context of a user session via the PID parameter. So again, exactly what we were looking for, where we were looking for it. Another echo of unencoded data. This resulted in another reflected XSS via a query parameter. So that is basically overview of how we identified an author that had committed known vulnerabilities, how we examined all of their commits, and how we identified some previously undiscovered vulnerabilities ourselves. Now, rather than have this be a manual process, it would definitely benefit from some automation. So I did actually start to automate this, but then I kind of went down a wormhole of using machine learning to try and identify vulnerable commits. But you can kind of use some of the Git Okay, so backing up, first of all, if you know what repository you're trying to attack, you might be able to parse that out of some of there's something called the National Vulnerability Database. Basically, it's a database of all of these CVEs. What you can do is parse it. And what I did was, while parsing it, if there were ever any references in it that were one of 36 or so known open source repositories, what I did was I marked that as possibly being an open source project that you could use this method on. So if those references to open source repositories were actually references to commits that fixed vulnerabilities, then you could kind of use this method. And what I did was, by doing that, able to identify about 3,000 or more open source repositories that this method might work on. Yeah, but additionally, what you could do, I think, that I haven't done, is rather than try and use machine learning to identify vulnerable commits, if you just did this process and instead of manually inspecting them, just hooked it up to a static analysis tool or something like that, you might be able to really just get away with automating this and making it a lot better. So maybe I'll do that in the future, but yeah, that's about it. I have some acknowledgements for my clip art and questions. Are there any questions?
I don't see any now, right now, Will. But we do have a channel for your talk in our Discord if you want to hang out in there for a little bit. Maybe someone might pop in for you.
Okay, yeah. Yeah, I'll just hang out in the Discord.
Yeah, thank you very much. That was a very interesting talk. It was really cool.
All right. Yeah, no problem. Thank you. Thanks for having me.
Enjoy the rest of the conference.
Yeah, you too.